As our civilization advances, our need for energy explodes, from the Stone Age's small fires to today's massive power grids. Our consumption has grown exponentially. In the 21st century, our energy needs are enormous, over 620 exajoules, enough to power all the homes in India for a year. But what happens when we need even more? We can't rely solely on Earth's resources. Where can we find such a vast and sustainable source of power? What if we could tap into the energy of our sun? It unleashes a mind-boggling 3.86 times 10 raised to the power 26 watts every second. That's an unimaginable amount of energy. But how can we begin to harness it? The answer lies in a megastructure called a Dyson Sphere. This concept was first proposed by a physicist, Freeman Dyson. He theorized that advanced civilization facing insatiable energy demands might eventually enclose their star to capture its immense power. He even suggested that we could detect these structures by the infrared radiation they would emit. The star's energy absorbed by the sphere would be re-emitted as infrared waves, which could be considered as a potential sign of extraterrestrial intelligence. Dyson's initial idea was to completely wrap a star with thousands of satellites. But this had major flaws. Imagine such a large sphere. What if an asteroid collided with it? The whole thing could be destabilized, and the sheer amount of material is quite staggering. We'd probably need to dismantle a whole planet to get the material. This would also likely require colonizing other planets first. That's why philosopher and futurist Stuart Armstrong proposed the concept of a Dyson swarm, a modified version of the Dyson Sphere. Instead of a single shell, the swarm would consist of countless smaller units orbiting the sun, each intercepting a portion of its energy. This swarm could then beam the power back to Earth. But even the swarm faces immense hurdles. First, the mechanical requirements are still astronomical. Then, consider the energy needed to build the swarm. Dismantling a planet and then processing the materials would require a massive energy input. Perhaps as much as 50% of the energy we would eventually get from the sun. Then there is the engineering. Maintaining the stability of countless objects orbiting the sun over vast periods is a huge challenge. We would need incredibly precise orbital calculations and advanced navigation systems to prevent collisions. Active maintenance using sophisticated robotics would also be essential. Now, let's imagine we somehow overcome all these challenges. What would happen to Earth? If we drained the sun's energy, Earth would become a very different place. Plants which rely on sunlight for photosynthesis would be devastated. The planet would freeze. We could try to genetically engineer plants to survive with less light, but the freezing temperatures would still be a massive problem. We would need a global artificial heating system, a monumental task with unknown consequences for the climate. It would essentially mean modifying the entire planet's environment. So, is a Dyson Sphere impossible for us? Yes, with our current technology, but perhaps other far more advanced civilizations have found solutions. Maybe they can harness energy on a galactic scale or even manipulate entire universes. These possibilities are mind-boggling, but they remind us of the potential for technological advancement. Perhaps one day we too will be capable of such feats. While a Dyson Sphere remains a distant dream, It's a fascinating concept that pushes the boundaries of our imagination. If you are curious about the universe and the future of humanity, subscribe to our channel and join us on this journey of exploration.